Good afternoon, viewers. Sorry, there was a technical glitch due to which the session has been delayed. No worry, we will carry on with the session. Today's topic is pointers in C programming. So, this is a very important topic, and then please concentrate on this particular topic. Why? Because this topic will be helpful for you in your due course of time, like while you are studying the data structures, that is MCS 21, and then in the third semester there is another course on design and analysis of algorithms. So this will lay you a good foundation, and then if you are through with the arrays, structures and pointers, then you will be very much comfortable doing the programming or else writing the programs using the other data structures. So in the earlier sessions, we have seen the preliminary aspects, and then we had seen the user defined data types that are arrays, and then in the previous session we have seen the structures concept. And when we normally declare a variable and initialize its value, a normal variable is a location in memory that can hold a value. So whenever from the programmer's perspective, whenever we refer to the variable, that is the name, the label that we had given, suppose int I is equal to 10. So I is a variable and is being initialized to 10 and it is of data type integer. So in some compilers it will occupy 2 bytes, and in some compilers it occupies 4 bytes. So for example, when you declare a variable I as an integer, in some compilers 4 bytes of memory is set aside. Normally we talk that it is of 2 bytes. So in your program, you refer to that location in memory with the name of the variable, that is I. So till now we are not referring to the actual memory address. So whenever we talk about or whenever there is a reference to the variable, obviously we are referring to that location and its value stored in that location. So at the machine level, when we see, this is the programmer's perspective. So at the machine level, that location has a memory address at which the number of bytes, the data type that it occupies. So let us define a pointer. A pointer is a variable that stores the address of another variable, that is integer I is equal to 10. I is the variable name given and the value of it is initialized to 10. As you can see at the machine level, I will be storing in certain location. So for each and every memory address, every memory location will have its own address. So for example, an integer variable holds an integer value. And then suppose if the address of that integer value, that is the address of I for example, is stored somewhere, that somewhere is not a normal variable, however we declare in the form of a pointer. So as you can see, pointers store addresses of the variables, whatever the data type it may be. Like suppose if I declare a pointer variable as integer, so it stores the address of a integer variable. So there is a big difference here, you can notice. Variable, it is separate, and if you capture the address where in which it is stored in the memory location and store that address, then it requires a pointer variable. So the next question comes here is why to use pointers, or else why to access directly the memory locations instead of the name given to the variable. Let us see the characteristic features, or else let us concentrate on the uses of the pointer variable also. In order to understand it better, let us see a simple example which is very much relevant. Suppose if you are living in some society, and then that society will have a name or else an apartment, wherein which you will be located in flat number 104. So it is the specific address, the area name, or else let us come straight away from the state, then city, then the area, then the society name, then your flat. So this is a kind of complete addressing scheme that we follow whenever we want to identify the address of a person. So the same way, if you want to access the variables with their addresses, so all the variables, whatever the data type it may be, those will be occupying certain memory locations. So those, if at all we want to access the memory locations, then the same way the value, same way whatever the addressing scheme that we are normally following, like in order to capture the addresses, some things are required. That something is nothing but the pointer. It is not a normal variable. However, the pointer variable stores the address, that is the underlying term, address of the variable. So whenever it comes to your mind a pointer, then it should strike that it is nothing but it is carrying an address. Suppose it is a simple variable, integer variable, the integer variable's address is been stored, or else the first location. Suppose it is occupying 2 bytes, the first location will be stored, and it says that it is an integer, it occupies 2 bytes. Or else if it is a float, in some compilers it will take 4 bytes. So the start address will be noted, and it will, as you are declaring the pointer variable as the float, it occupies 4 bytes. So right now it is clear to you that what is the difference between a variable and then what is a pointer variable. A variable is a normal variable wherein which we are using it in the programs in order to carry out in order to store the values during the course of time of the program. But however, when we talk about the pointer variable, it stores the addresses of the variables. So a pointer in C is used to allocate memory dynamically at runtime. The pointer variable might be belonging to any of the data type, as I told you, like it may be an integer pointer variable to a float, character, double, short integer, long integer, whatever the case it may be. So let us see the characteristic features of the pointer variables. So how these pointer variables are helpful during our programming? The program execution time will be reduced because we are not accessing the values or else the variables by its name. We are accessing it by its reference, or else directly the memory locations are being targeted. So obviously the execution time will be faster, will save the memory space. The memory access will be very efficient because we are randomly talking about the address. Directly it will go and search the address, fetch the value and performs the calculations or manipulation. Dynamic memory can be allocated, like instead of the static memory. Suppose if you are having an array, character array of size 25 you had declared. However, in most of the times it is having only 2 characters. So it is wasting the memory. Likewise in arrays, structures, most of the memory space will be wasted. Suppose if you have this pointers concept in your mind and access those structures, functions, arrays with the help of the pointers, which we will be looking into the due course at the end, towards the end of the session, how to use these pointers with arrays, structures and other things. So dynamically you can allocate the memory. wherein which you can cut short the wastage of memory, because in the system the primary expensive thing while the program execution is one of the thing is the memory part. So whenever you talk about the static kind of allocations in certain programming languages, they themselves have the fixed boundaries in place, and even though it carries less values, even whatever that is been allocated, the space allocated or assigned for those space will be taken as the total space. And then the next is the use of pointers. So characteristics we had seen. So what exactly are the uses when you program it through the pointers? So they are used to create dynamic data structures. C uses pointers to handle variable parameters passed to the functions. In the earlier section, when we talk about the functions, the arguments whenever you pass, directly you are passing it by call by value. So if you refer those things with the help of pointers, that is accessing the address kind of thing, then obviously the execution will be faster, and then exactly the whatever you are that the address is intended to fetch, it easily fetches the value and performs the functions execution. So pointers in C provide an alternate means of accessing information stored in arrays, which is especially valuable when you think of its value